Hi, thank you for coming to my talk. This is 4 weird Google VRP bugs in 40 minutes by me, David Schütz. You might know me as xDavidWho online. So, let's get started. We are going to talk about 4 bugs today in 4 different Google products. The first one will be in Google Assistant, then Sign in with Google, then Google Script, and the final one will be Google Classroom. So let's get started with the Google Assistant bug. What is Google Assistant? This is an interactive personal assistant by Google, which is the competitive product to Apple's Siri and Amazon's Alexa. You can ask different questions from Google Assistant and it can even act on your Google account or on your devices in your home. We can even try it. Hey Google, turn off the lights. There it goes. Now I have to turn these back on again. And there we go. So, while looking at Google Assistant and Google products as a whole, I noticed something interesting. In a bunch of Google applications, there is a square app drawer on the top right corner, which when clicked opens up a list of different Google products. These products can be clicked on and they will be redirected to the given product. So this is a very simple redirect. But when visiting the google.com from a mobile device, I noticed something interesting. In the app drawer there was a new Assistant app showing up. When you clicked on this link, it started Google Assistant on your phone, and Google Assistant started listening. So basically, just by clicking this link, you were able to trigger it. And it worked by using a deep link. So the link that this button redirected to was this Google app deep link. And this in turn triggered the Google application to start Assistant. So this is interesting because I thought if this is a simple link, then I could also trigger Google Assistant from my own website. Also, at the time of finding this bug, I was searching on Reddit for exactly this kind of stuff, and I found a person named Naked42long showing an automation around how he hacked Google Assistant and executed commands automatically. The author published a flow for the Automate Android app, which was able to execute Google Assistant commands without any permissions. It simply triggered Assistant with an intent, and after waiting 1 second it started speaking the command out loud using a text-to-speech engine. And this actually worked. This was a bug on its own and it was publicly available on Reddit. An Android app without any permissions should never be able to talk to Assistant in your name with your account and control your devices and access your information. Knowing about this trick, thanks to Naked42long and the previous deep link, I thought I could put the two together somehow. So, on my own site I made this simple A tag which pointed to the deep link I have previously found. This when clicked by the victim opened up Google Assistant and the Assistant started the listening for commands in the foreground. And my website was still running in the background. In the proof of concept I made, you can see that there is also a function getting called when the user clicks on this button, and it's called Open Door. And here is what this function did. It basically played an audio file on the page with JavaScript. What's inside this audio file? It was a simple text-to-speech machine saying open the front door. Since we have just triggered Google Assistant via the deep link, she will hear it and process the query when we play this audio file via JavaScript. But the query will be running in the name of the victim's Google account, since it was the victim who triggered this Assistant. So this is a bug because an untrusted website was able to trigger Google Assistant and then actually start talking to it. Here is a proof of concept video of this in action.
Open the front door. Sorry, it looks like that device hasn't been set up yet.
There it is. We triggered Assistant and then talked to Assistant and said open the front door. A disclaimer here, as far as I know, it's not this easy to open a door with Assistant. It's supposed to ask you for a PIN code, but I used this for the demo since it sounded the most cool. It just proves the point that you can execute any command on the victim's Google Assistant. I thought I could take this a level further, and if we can talk to Google Assistant once, we could do a full-blown conversation with her. So here is an example of this, which after one click on our link automatically sends the victim's location to attacker in an SMS message. I think it's pretty amazing because it's two robots talking to each other. Let's watch the video.
Share my location with.
Who do you want to share it with?
062098076991.
Text test phone number. It's not actually
I
live
have the text
anymore.
ready with your location. Do you want to send it or add text?
Send it.
Okay. Message sent.
And there is the message, an SMS message with the location of the victim. So I think this is pretty amazing. Not really practical, but pretty amazing. And it got a $500 bounty. And I thought, okay, this is what it is. That will be the final bounty. But a few months later, I got a new message saying that, hey David, we were reviewing past VRP reports for our end of the year review, and it came to our attention that your report was not correctly assessed. And they want to send it back to a second round to the panel. I was like, okay, sure, send it back to another round. That's great. And in the other round, it got an extra reward of $4,500, totaling up to $5,000, which is a standard range for Google bounties for around this kind. So it initially got fixed by completely disabling the deep link. And this also broke the assistant button on google.com, but more than a year later, I clicked on this button once again by, I don't know, just by browsing on my phone and click on the button, and Assistant came up once again. So I thought, wow, okay, does that mean that I can execute the attack again? I can bypass the fix maybe? And turns out yes, but there was some weird protections that made it harder. So now if my site started to play the audio, Assistant gave me an error message saying Assistant can start when another app is using the microphone, which is a weird error message, but it kind of worked. So I found a way to trick this. I figured out just by trial and error that if I started to play music beforehand and music was playing before triggering Assistant, this error did not appear. And Assistant heard my command on the second try. Actually, this is really just like crazy stuff at this point, but I was able to bypass the fix via a very weird exploit. So here is that in action.
Turn the lights red.
No music is playing, Assistant is giving the error message.
Turn the lights red.
Starting the music.
Turn the lights red.
I didn't quite catch that, try again.
Turn the lights red.
There it goes. It turns the lights red and it proves that you can execute commands in the victim's Google account. And it got an additional $3,000 bounty for bypassing the fix. I think the takeaway from this is that microphone input should not be trusted. Since the voice can't be trusted, do not let a third party start an authenticated listening process in the name of the victim. This is what happened here. Like, I was able to, from my untrusted website, start an authenticated listening session and then just type untrusted voice into that session by playing text-to-speech audio via JavaScript. So the next one is sign-in with Google. What is the product? Google Sign-in allows websites to use Google to log their users in, and it also allows them to basically ask for permissions for specific account resources, and if the user provides the permission, the target application will be able to access those resources and use those features in the name of your Google account. This is actually called OAuth, and this is the name of a standardized flow that is offered not just by Google but many other providers. This looks like this in a very simplified way, that you have a target website which wants to log in with Google, and it redirects you to Google, which asks you if you really want to sign in or not. And if you select yes, I want to sign in, the Google redirects you back to the target site with a specific token that the site can use to access your data. To start this login flow, your site has to redirect the user to Google. The initial URL to Google looks something like this. The relevant part here is the scope section. In the scope section, you have to provide which permissions you want to ask the user for. So in this example, we are asking for adverts and Gmail access, and it's up to the user to actually decide if she wants to give that access to you or not. From the user's viewpoint, the user will first see this choose an account screen, which you might have already saw before. It's basically a list of Google accounts you're signed into, and you have to select the one you want to use. After selecting that, if the application requires more sensitive scopes and actually wants to access your data on Google, then a second screen pops up where you have to accept or deny these specific permission requests. This looks a little bit different than when I found the bug, but the core logic is the same. There are checkboxes on the side, and you have to check them if you want to enable the given permission, if you grant the given permission, and uncheck it if you don't. It's unchecked by default. I also noticed that there are two buttons on the bottom of the page, per privacy policy and terms of service, which when clicked basically redirected to the pre-configured privacy policy or terms of service links by the given application. You could set these links up in Google Cloud Platform, and it's very simple string. You just put your application privacy policy link and terms of service link and click save, and after that, when people are logging in, they will be able to click on these links and get redirected to your site. So while I was testing this, I was basically testing the whole login flow, and I was looking at the proxy logs of every different step to try to find something to attack. And I clicked on this link and it got redirected to my site. And in the proxy logs I saw something very interesting. This was the request going to my website. A simple GET request to the /privacy URL. A GET request is normally pretty small. It only includes the URL, user agent, and a few other data parts. But here it was big. It was big because it included a referrer header with the whole URL inside it. The referrer header is intended to contain the URL of the previous page that opened your site. And here it actually contains the full URL of the Google accounts page that the user clicked the terms of service or privacy policy link on. It was pretty interesting because it included, as you can see, some very long and sensitive values, such as the part parameter and the approved scope parameter. The part parameter, that's the big one, it was the token that identified your current state in the OAuth flow. And I think it was some kind of, and still is, some kind of encrypted data. this should not really be public. It's only in the URL for the user while performing the login flow. But now we have access to it via the referrer header. The other interesting parameter was the approved scope parameter. This, used at the time, included a list of scopes that the user has pre-approved with a pop-up. Because previously there was a pop-up for every permission requested and you had to choose accept or deny, and at the end it showed you a summary of your choices. And in the URL it saved these choices using the approved scope parameter. Essentially, basically, if you had the scope in the URL, then in the page the checkbox was in a checked state. So at first I was really hopeful and I wanted to take this to a full account takeover attack. Because I had the port parameter, I had the approved scope parameter, I had a bunch of other parameters in there like the reauth proof token, rept token, that's the same, and the AS token, which looked like a CSRF token, but none of these tries worked and I failed to escalate the impact. I wasn't able to automatically grant scopes or take over accounts or do anything like that. So I had to fall back onto a more lame attack scenario. Here is what I was able to do. Whenever the victim clicked on the privacy or the terms of service links, I got the referrer URL in the request to my site. So since that URL had all of the necessary parameters for the flow to work, I could now redirect the victim back into the OAuth flow to the same state at which she clicked on the link to my website. And since I had full control over the URL and the approved scope parameter in the URL, I could just add all of the requested scopes into the approved scope parameter. And when redirecting to this now malicious URL, the victim will have all of the checkboxes checked. So this attack relied on the victim not noticing this and clicking continue and not removing the checkboxes and granting scopes that the victim didn't intend to grant. This was a little bit of social engineering. Also, the privacy links opened in a new tab, so after my attack they got redirected to the login flow in the new tab, so they had two tabs open. So again, I had to rely on the victim not noticing this. Here is how the proof of concept script looked like. It first parsed the URL from the referrer header, printed the contents to the page because it looked cool for the video, and after waiting 5 seconds it also added the YouTube scope to the approved scope parameter and redirected the victim back into the login flow, where the YouTube scope was now checked. This is here in action. We are on the OAuth playground tool to more easily test these flows. That's where we start the flow. We select an account again because of YouTube brand accounts, and then we get this verification warning. This is because an app has to be verified to access sensitive scopes. In the real world, a verified application could also go malicious, so a verification is not really a protection for this vulnerability. So after that, we get the pop-up saying they want to grant the YouTube permission, and we click deny. We get to the summary page and YouTube is unchecked. And we click on the terms of service. In a new tab, our malicious site opens and it prints out the contents of the referrer URL. And in 5 seconds, it's going to append the YouTube scope to the approved scope parameter, which is now empty. And as you can see, we got redirected back, and the manage your YouTube account is now checked. So if the user clicks allow blindly, then the YouTube permission will be granted, which the user denied beforehand. Okay. Unfortunately, this still required some social engineering. First, not notice the multiple tabs, and second, not notice that the scopes that you didn't previously approve got checked. But still, it got a $6,000 bounty. I was pretty surprised about this, and I thought it was a pretty lame bug. Turns out it wasn't. And I asked why the bounty is so big. I thought that they maybe internally found a way to take over an account or to, do the stuff that I wanted to do, but I wasn't able to do it. But turns out, no. They said that basically having tokens with the scopes that the user didn't as explicitly grant is similar to impact-wise to an XSS, which is a $5,000 reward. Also, because they liked the proof of concept and it was a surprising vulnerability, they added a $1,000 bonus totaling up to $6,000. The takeaway here is to set a strict referrer policy on your website, which can be used to limit the referrer URLs that outgoing requests have on them. You can set it to only include the origin of your site and not the actual URL, which can contain sensitive parameters. I think Google didn't really use this parameter, they used some kind of other magic, but in any event, currently this is fixed, and now clicking the privacy policy link only sends the refer header accounts.google.com in the refer and nothing else, so it cannot be exploited anymore. The next bug, we have to hurry because 4 bugs in 40 minutes is a lot and I only have 10 minutes per bug. So the next one is the apps script bug. What is Google Apps Script? It's basically a tool to automate workspace products, to automate Google Docs, automate Google Sheets, Google Slides and of that kind. You can do this by writing custom JavaScript, which is interesting and the attacker's viewpoint. A warning and a disclaimer here. Unfortunately, this bug I'm about to show you is still live and I wish it wasn't really. I always try not to publish bugs that are not fixed. After talking with and warning the Google VRP team, I decided to keep this bug in the presentation and disclose it today. I have reported this issue 1.5 years ago in February of 2020. After being unfixed for this long, I do not think it is beneficial to keep it as a secret anymore. But I am really sad to see a bug not get fixed for this long. Unfortunately, this is not the first time this happens. The classroom bug I'm about to show you later was also unfixed for almost 6 months. In my opinion, that's way too long for a security bug, especially for that impact. Even though it's probably very difficult for the VRP team to prioritize and fix all of these issues in a reasonable time, Google, please try to do better. Finally, it's worth mentioning that unlike some other companies and bug bounty platforms, Google does not restrict the disclosure of these potentially unfixed issues. They have always supported me if I decided to go down the road of public disclosure. So, in AppScript you can make scripts. Not so surprising. These scripts can do multiple different things, but what we are interested in is the triggers for these scripts. Setting up one of these triggers help you automatically run your script when a specific event occurs. An example would be to run a script every time a document is open. So you would set up an onOpen event on a document, and whenever that Google document is opened by a user, your script will run. When testing this, a simple attack idea of mine was to try to set up a trigger that points to the document I do not own, a very simple IDOR. So whenever that document is opened, my script would run and potentially access the details of the event and maybe contents of the victim's document. I wanted to try that. To do this, I had to edit a pre-existing trigger via the UI. It was a bit hard to actually make the request, but first what I did was I created a onOpen trigger for a document that I owned in a script. As you can see it right there. So when I ran that script, it created the trigger for my own document. After that, I opened the trigger app in the UI and I clicked on edit and I clicked on save. And before saving my non-existent edits, I started intercepting the traffic with VRP, the HTTP proxy. And in the HTTP proxy, I found the request going out to edit this trigger, and this trigger included the ID of the target document, my own document the event was bound to. So I swapped the ID of my document to the ID of the victim's document I didn't have access to. Of course, for this you had to previously know the ID somehow. This is a classic limitation of these IDOR attacks, and it applies here as well. You have to know the ID of the target document first. But I swapped the ID of the event, and it saved successfully. And the document and the trigger was now pointing to the victim's document, the onopen trigger. With the victim, I wanted to try it out, and I opened the target document. Unfortunately, my script didn't run. It displayed a warning message saying that the trigger is disabled because, quote, you do not have access to the source of this trigger. Unfortunately, it was right. This was well protected, and I had to find another way to exploit this. Did I trick you there? Did you also think that this is secure? Or did you catch what happened there? Actually, this behavior is the bug itself. As you can see, it correctly gave me a permission error, but only after the victim opened the document. So when the event got triggered internally, it checked my permissions and disabled the trigger since I did not have access to the source of the event. But by doing this, it basically indirectly told me what I needed, that the victim opened the document. I think this is very cool. And I made a proof of concept for this, which created a new trigger and started polling its state every second or so. And as soon as the trigger got disabled, it told me that the victim opened the document and made a new trigger and started polling its state. And it did this in a loop. To clear up any potential confusion using this bug, we were only able to tell if a victim opened the document or not. Unfortunately, we couldn't access the details of the event or get the contents of the target document. So this was just did the victim open it or not? But this is also a bug, and sensitive bug itself. Here is the video. So at first I have no triggers. Then I go to the terminal and I start my Python script, which creates a trigger and starts waiting for events. Now, when I click on the document with the victim, I open it with the victim, my script on the right, in a few seconds, it notices and prints out that the victim has opened the document. And it deletes the old trigger, recreates the trigger, and starts waiting again. So I refresh the page with the victim, triggering it once again, and the script on the right, in a few seconds, actually realizes that the victim has opened the document once again and recreates the trigger and starts doing this in a loop. So this got a bounty of $3,000 because I was able to tell if a victim and when a victim has opened a document or any other Google Drive, Google Workspace file, really. The takeaway here is that a permission error could be the bug itself, and I hope I was able to trick you for a few seconds in the previous slide, making you think that this behavior was indeed secure. But sometimes giving a permission error could be the bug. The next and the last bug in today's talk is the Google Classroom bug. What is Google Classroom? Google Classroom, you might already know it based on last year's events, but it can be used for online education, and it is a tool mainly for teachers to share information with students. The teachers can assign tasks and share documents and information with the students. Classroom loves Google Drive, and they have many interesting integrations under the hood. And as hackers, we always get suspicious seeing integrations such as this one, since most of the time these open up a brand new and interesting attack surface. One example of these integrations is that a teacher can attach a Drive document to an assignment and share it with the students. It can even be configured to make a copy of the given file for each and every student in the classroom. As you can see on the GIF, I'm making a new document and I can change if the students will be able to read it, or I can make a copy for each and every student. Interesting. And from the student's viewpoint, there is also some interesting things happening. A student can add documents to an assignment, and after finishing their work, they can turn in the assignment. So we write something there, and then we can click on Turn In. And turning in an assignment causes the ownership of the document to change from the student to the teacher. And it gives the student only read-only access after you turned in the document. These are a bunch of really powerful under-the-hood integration actions on Google Drive files. This is an interesting area to look for security bugs as well. When a teacher attaches a document to an assignment and sets its mode to make a copy for each student, all of the students receive a copy of that file, which is then placed inside a shared classroom Google Drive folder with editor access given to the teacher. So every student will get one file and they will all have access to it, and the teacher will also have access to all of the copied files. As per usual, I wanted to see what happens if I create an assignment which has a document attached to it that I didn't own. For this, I made a new assignment in the UI and started intercepting the requests when I hit the Save button. And I also attached a document to it, but the ID of which I wanted to swap. So, after intercepting the saving request, I found that there it is, the ID of the document that I want to attach to this assignment. So I swapped the ID to a document that I didn't have access to. Again, I had to know the ID previously. At first, when I attached it with the normal students can view this file mode, it saved it, but later it only displayed drive file, unknown file. Basically, when you later checked the assignment, it was loading the preview for the attachment with your permissions. So if you didn't have permission, you simply got drive file, unknown file. This was not really exploitable. But something happened when I set the type of the attachment to the special make a copy for each student and swapped the ID to the victim's secret document who was inside my classroom. When saving this assignment that had victim's private document attached to it, Classroom wanted to, as described, make a copy for each user. This file copying logic worked in a way that it tried to make a copy from each of the students' perspective. This is very important. So the copy for every student was made from the given student's perspective. Since the victim's private document was attached, this logic tried to make a copy of the victim's document from each student's perspective, but for every single student, this copy failed, except for the victim, since the victim had access to the file, since it was the victim's secret document. So, because of this, when the teacher created this malicious assignment, the victim's private file automatically got copied into the shared classroom folder, and editor access was given to the teacher. From this point, the teacher only had to check the shared drive file or the assignment from the classroom UI, and she was able to see the complete copy of the target document without the victim ever giving permission. So here is the proof of concept video for this. We have two classrooms, well, one classroom and two users. One on the left is the teacher and on the right is the student. And the student is inside the teacher's Google Classroom. So we create a new assignment. We enter some title and we create a new document. After the document gets created, we change the attachment type to make a copy for each student. Before clicking Assign, we also copy the victim's private document. This is a private document, as you can see by the lock icon. This is not shared with anyone, and it includes the text saying this is the victim's private document with sensitive information. We first copy the ID of this file. Again, we have to know the ID beforehand somehow. So before clicking assign, we start intercepting the requests, and then we find the edit request in the proxy logs, and then we select the ID of the document and swap it to the victim's private document. The assignment gets saved without any errors. Now, as you can see, the teacher is actually not seeing the file. It's seeing drive file, unknown file, since the teacher doesn't have permission to the target original file. But by clicking View Assignment and clicking on the victim, it will load the victim's copied document. And I have, as an attacker, editor access to this document at this point. So I can just simply open this copy in the shared classroom folder and see that this is the victim's private document with sensitive information. This bug got a reward of $5,000, a pretty standard range for IDOR bugs of this kind. After a while, a fix rolled out, which changed this attachment flow in multiple different ways. To be honest, I'm not 100% sure if this new template feature got added after my report or before it, but I only noticed it after. This new make a copy for each student flow looked like this. First, the teacher saved the assignment, which had a document attached to it. Second, the classroom tried to make a copy of the document from the viewpoint of the teacher. If that was successful, then the copy was saved as a template in the Google Drive folder. After this, the students were now making a copy of this template and not the original document, but the template. This forced the teacher to only attach a document that she had access to, otherwise the template creation failed and no copy could be made by the students. This is where the templates were stored in the shared Google Drive classroom folder. That caps lock do not edit is kind of sketchy and funny at the same time. It kind of makes you want to edit it. So I was messing around with this new fix, and I found that while I can't really make a new assignment with the victim's document attached to it, I could still almost fully edit a pre-existing assignment. So creating an assignment with a document that I owned and then clicking edit and capturing the assignment edit request from the UI, we can see that now there are two different IDs in the assignment. One is the original source document's ID and one is the template's ID that got copied to everyone. You already know what's going to happen. We are just going to swap the template ID and set it to the victim's secret document. After this, I also had to delete the victim's already existent copy from the original template from the shared drive folder, but it was no problem because I had access to that file, so I was able to delete it. So since the victim's copy for this assignment was deleted, when visiting the assignment, the victim got prompted to make a copy. But if you take a closer look, now the target document is victim's secret doc, which we swapped the ID previously to. If the victim didn't pay enough attention to this, she might have simply clicked the Make the Copy button, which would have instantly copied her private document into the shared Google Drive and gave the teacher access to it. Once again, this required some social engineering and making the victim click on this button, and it was not the best attack. Even though this was not that easy to be exploited, I wrote my findings down in the issue ticket. 13 days later, I received a reply saying, "Hi David, thanks again for the new details. I don't think it's just an abuse. I was able to find a way when the click of the victim is not necessary. but also it seems to be a different root cause than your original fixed attack scenario. The fix is not yet ready, and I have sent this report again to the VRP panel for their consideration about a potential reward. And indeed, a few days later, this bug got a second $3,000 bounty. Kudos to the VRP team for finding this bug and still paying me out for it, since it wasn't me who found out how to fully bypass the fix. I still don't know how they managed to pull it off. I think the bounty amount was rewarded, since my findings led them down the path of finding this new bypass. But again, this approach of giving me the bounty even though I was not the one finding the bypass is really cool. The takeaway here is that permissions don't offer protection if the action can be initiated by the third party. So I think this is interesting and kind of scary takeaway to think about in terms of your own applications. That is it the user who initiated the action? Because even though the action seems okay, since the victim has access to his or her own document, it might not be the victim initiating the action, as in this case it was the teacher who was initiating the copy action in the name of the victim. So this was it. I hope you enjoyed this for Google Bugs, and thank you for watching. Bye.